The basic definition of a limit is this. The limit of f of x as x approaches a equals L. We can see here in the graph that we have some random function called f of x. The function itself has a value called a, and as we see on the left and right, as we drawn in the red arrows, as x approaches to a, the function itself approaches L. And it doesn't necessarily have to equal L, but it will approach it. Say, for instance, we have this example. The limit as x approaches to 1 of x plus 1. You can see here I put on a table all the different values as we approach 1. We can see here that as x gets lower and lower, or closer and closer on the right side, it's approaching 2.0001. We can see on the left side that it's also getting pretty close to an odd number. In 0.99 or 0.999, we can see here that it approaches this one value. We can make the claim that the limits as x approaches to 1 of our function approaches this number. It necessarily doesn't have to equal it, but it will approach it. This idea can even be simplified by not even showing a table, but it can be shown algebraically, where we can see that the limit as x approaches to 1 of x plus 1 can be just written as the limit as x approaches to 1 of 1 plus 1, which gives us 2, which lines up. So there are two ways that we can find limits: using a table and finding out values that are close to it, and at times algebraically.